Hello, welcome to our final video for our facility redesign senior project with Poor Richards Press. I'm Rebecca.
And I'm Charlie.
Within the next few minutes, we'll be going over some background information on the company and the project itself, an overview of the current state, our designs for improvement, the corresponding methods and testing strategies, the resulting recommendations, business case, project impact, and ideas for future studies. Poor Richards Press is a local general commercial printing company, meaning they produce everything from posters and banners to mugs and shirts. They also have a high-mix, low-volume output that introduces a multitude of variation in their already custom-ordered products. Based on financial data from 2017, approximately 83% of their profit comes from digital printed products, utilizing methods similar to laser printers found in homes and offices, but on a much larger scale. After determining that the digital department was the most critical within the company and discussing performance issues with the business owner Todd, the problem statement was seen as such. The average cycle time of the digital department does not meet the company's goal by 10%, which cost them approximately $96,000 in 2017. Within our previous video, we discussed our define and measure phases within the DMAIC process. Within this video, we'll be covering analyze, improve, and control phases with special focus on our facility designs and the simulation package used to test the alternatives. Next, we'll be discussing the current state of PRP's digital department performance. To help you visualize the upcoming information, here is the actual current layout of the 100 by 80 foot facility with digital circled in red, which we will go into more later on in the video. Based on time studies and the historical data received by the company, we were able to calculate the cycle time of each department that was significantly related to digital. In order to compare these cycle times, each cost center's figure was normalized based on how often a job actually featured that element. Thus, more frequently occurring jobs had a higher weight than those that occurred rarely. In this Pareto chart, we can see the normalized cycle times weighed against one another and can determine that the digital department itself, where printing takes place, is the bottleneck of the process.
During our Gemba walks around the plant, we recorded observational data regarding the 7 deadly wastes for multiple digital runs. The biggest cause of waste was because the operator was walking outside of the digital area, usually to communicate with another worker or to gather or drop off materials. This wasted time accounted for about 11% of the total run time we observed. 6% of the run was wasted by talking to another worker, oftentimes to clarify questions about the job or to seek help to solve a problem. Finally, 4% of the runtime was wasted by what we called the other category, which is mostly comprised of the operator being idle or wasting time searching for something.
After determining that transportation was the largest sort of waste within digital, we decided to pursue a facility redesign that would minimize the necessary amount of walking outside of the department. Here is the first half of our VSM that focuses more on the flow of work in progress and information, with cycle time data already calculated on the side. The number within each row represents the number of interactions between the two departments. These interactions between departments were summarized in a relationship table that allowed us to visually rank the importance of relationships based on quantitative data. The green cells indicate a relationship of absolute importance, yellow shows important relationships, orange normal relationships, and red unimportant or undesirable relationships. The strength of a relationship on this scale helped determine which departments should be next to one another in our facility designs. Before we begin talking about all our alternative designs, let's take a better look at the current layout. The highlighted path represents the most critical flow of digital products, which account for about 40% of all digital jobs that flow through. Even though the digital department has strong ties to departments in the top right corner, it is placed in the bottom left to maintain a large but circular path through the plant. In this state, jobs that flow through this path have a cycle time of approximately 1.3 hours. For our first design, digital is moved up closer to shipping and its source of raw materials while moving trim and folding equipment to the side. This design was achieved by optimizing the digital department alone as the first priority. This meant that all relationships for digital, as seen in the table to the left, took precedence over other departments' relationships, even if they were classified as absolutely necessary. Because of this narrow focus, only 3 departments were moved, which means that the cost of moving equipment was minimized. The design also fulfills the 2 major requirements as outlined by PRP, that the offset department, or the big blue area to the upper left, cannot be moved, and that main aisleways must be large enough for forklift traffic. In our second design, there is similar movement from the last design with additional movement of multiple post-printing equipment, the small offset printer, and the large format printer. This design meets the same requirements and was based on the goal of satisfying all absolutely necessary relationships within the plant, in addition to those of digital. As seen in the table, the green cells under 4 other departments drove the additional changes mentioned previously. While more machines were moved and increases the cost, this digital design achieves plant-wide optimization with minor sacrifices towards the digital department's lower priority relationships.
In order to test our design, we used simulation software in the form of Simio, which we learned about in IME 420. Most of the data input that went into each of the models was derived from the 2017 historical data that the company gave us. We also used some observational data to drive our model logic. Finally, we took measurements of the facility and all of the equipment and machines inside of it to accurately create the current state and alternative layout designs. Our primary key performance indicator was average cycle time for each digital job, starting from when the operator picks up a job ticket and gets to work on that job, and ending when the job finally exits the facility through the exit sync. The main software tools that we used to create the Simio models were Microsoft Visio, which we used to make the layout with accurate dimensions, Minitab, whose box and whisker plots we needed to remove outlier data points from our historical data, and At Risk, which is an Excel add-on that can be used to fit data to distributions and perform inferential statistics on them. Moving along, this is what the current state looks like when modeled in Simio. All of the machines and paths are drawn to scale according to the Visio layouts that we had. As you can see, we do not have every machine in this model, only the ones that are closely related to the digital printing processes. Here is the digital specific model in Simio. You can already see that a lot of the machines are more close together up in the top right corner of the facility, but not all of them were moved around. Here is the ideal layout. The ideal layout design is very similar to the digital design in Simio because all of the models only show digital related cost centers. If we included all of the other printing processes, this would have many more differences than the digital specific one. We used the experiment function of Simio to test our KPI, and after 300 replications for each of the 3 scenarios, we found that both digital and ideal scenarios had roughly a 7.8% reduction in the average cycle time of a job. This difference tested to be statistically significant at a 95% confidence level. Moving on to our recommendation, we determined that a 7.8% reduction in cycle time would lead to an annual savings of about $74,500. Although it isn't quite reaching our goal of 10% reduction in cycle time, we still consider this to be a successful figure. As for the cost of implementation, most of the expense will be from hiring electricians to come in and rewire the electrical infrastructure of the facility to accommodate the power needs of the machines and their new locations. Because digital has fewer location changes for machines, it has a lower estimated fixed cost of $11,500. On the other hand, the ideal format state design has an estimated cost of $13,000. Despite the fact that the ideal state is $1,500 more expensive, we recommend implementing it over the digital specific one because of the qualitative benefits that it will bring about. For example, the ideal layout simply has the best circular flow of materials, processes, and people, which could provide for increased simplicity and organization on the production floor. Speaking of qualitative benefits, Besides circular flow, there would also be a decrease in the distance that workers have to walk to be able to communicate with each other, should they choose the ideal format. This is important because it means there will be more opportunity to collaborate and work as a team to get certain problems fixed. For the economic analysis, we found that reduction in cycle time could lead to approximately $74,500 saved annually. The estimated costs that we determined for the ideal state layout were based on past electrician invoices for similar projects over the last year, and they came out to be $13,000. This means that the payback period will be about 2 months, depending on how slow or fast the season is at the time. We took a look at 3 different types of impacts that this project could have: environmental, ethical, and organizational. For the environmental side of things, this facility's redesign could cause waste in electrical wire, which are non-biodegradable. Also, electricians coming to and from the site will be giving off fuel emissions by driving. We have some positive ethical impacts from our project in the sense that safety equipment in the plant will be more accessible, and there will be more spacious and safe aisleways too, for forklifts and things like that. For the organizational impacts, there might be reason to cut a few hours off of the digital operator's schedule if their cycle times are affected enough by the redesign. This could also be seen as an ethical impact. On the brighter side, there will be more opportunity for workers to interact with each other because of their closer proximity to each other. Unfortunately, due to time constraints, we were not able to get to solve every problem we found during the project. Here are some recommendations for future studies that we have for anyone who might be interested. First and foremost, the current cost center logging system is somewhat time-consuming and not entirely effective. We have asked multiple employees how they go about logging their times for each job, and almost always there are discrepancies between each worker's method. For example, one worker might take the time to clock in a file imposition, even though it might take more time to clock in than the imposition process itself. Another operator doing the same job might just skip the clock-in process just to save time, losing that data. A reasonable project for the future would be to figure out a good way to automate, standardize, and simplify the data tracking method. Another potential issue that we came across during our time at PRP is the lack of prioritization and organization of job tickets at the digital area and at other cost centers as well. Oftentimes, when beginning a new job, the operator will manually sort through a pile of job tickets to determine what job should go next. Once chosen, the operator has to pore over the ticket to find the necessary material requirements to complete the job. We think there could be a better job ticket system with less brain work and less time wasted from a future project. Finally, we recommend taking a look at the other cost centers that we just didn't get the chance to look at for this project. Thank you very much for your time. We hope you enjoyed.